I will also share my video as well as slides so that you can again revisit what we discussed. Um, so let me start with the plan for today. I'm going to talk about briefly the course content as well as examination. And then I'm going to briefly talk about some introduction to the module as well as briefly discuss some of the applications. So assessments are like this for this. We will have some portion allocated for class participation, meaning that sometimes I used to have some quizzes, small activities within the class, and you can earn some marks on that. And then we will also have some practical sessions, which I will discuss. And then depending on your workload, we can also have a project on the same. It will be usually group work, which will worth around like 35 marks. And then as examinations, we will have two examinations mid around like 20 and end around 40, right? Sometimes when the coordinator allows us to have more assessment oriented, sometimes I used to change in semester to more or less the assessment. That means in machine learning, what we could do, we can have a competition like session for a couple of hours, and then we can evaluate that. So that up to us to discuss yet, but this is roughly my plan for the assessment. And then the main software tool, I'm going to use Jupyter Notebook, and Python will be the main programming language I'm going to use. But depend on our requirements, sometimes I might use R as well. But mainly I'm going to use Colab. So that's mainly the software tool that I'm actually going to plan to use within the classes. I have a couple of textbooks and then some online material I'll be using. Those will be posted in the LMS, so you'll have access to them through the LMS. Always refer the LMS for updated content. Majority of my slides will come from this book. This is a bit old, but this is the fourth edition of the book. Before we have, data science or machine learning, we already had, but as a area we had called it as data mining. So, and machine learning will be a part of it. And originally our syllabus is on data mining. So I'm going to use this book, but more towards the content will be oriented towards the machine learning stuff. And you are also free to let me know what topics you would like me to talk during the course. There's another book on the same topic by Han, and in this one also, this is more on problem solving nature of textbook. Those who wants to have a theoretical understanding of these machine learning algorithms, I highly recommend reading these books. For example, the first book I have been using since 2006 for teaching machine learning courses, where I started with Veka, which is a Java-based software at that time. And there they very simply talk about the how the algorithm works, the parameters, as well as how you may actually choose like the type of problems for your problem domain. But more recent and more practical oriented book written by Andrew Neck, which is one of the senior persons, where he's the person behind the open AI, the chat GPT. All these is Andrew Neck. He has actually written a book on machine learning yarning, talks about the applied machine learning. We are more on practical stuff. If you hear or read his work, In recently, he talks about with all the AI boom happened last 1 year or so, our machine learning model development has changed starting from 7 months to a couple of days time. So although early days when I teach machine learning, we used to say that you have to spend like 6 months or so. Now with the assistance of machine learning, sorry, artificial intelligence tools, you can develop, models, the production level models within couple of, days or weeks. Things have changed over, I think, the last 1 year or so. Right. So, I mean, there are plenty of content which time to time I will post it in the LMS for you to refer. But if you are a beginner, or if you have not done in depth, maybe it's a high time that you spend some time reading and also referring this material on machine learning. Right. So now the planned content, this is slightly different from the original one. What Dr. Wan advised me is focus more on machine learning or vision type of course. The right now the content I have put it here is more on machine learning stuff, but still we can talk in deep on recent ones. For example, my work in postgraduate studies, where I worked in dimensional reduction, which means how to reduce high dimensionality into more manageable dimension using various dimension reduction methods, and then how to fuse or how to combine the outcome of those dimension reduction methods. Okay. So first couple of sessions, I'm going to talk about the introduction to the field, what is coming, and also like what do you mean by exactly this representation of knowledge. And then we are going to talk about basic machine learning algorithms. When I talk basic machine learning algorithm, we are going to talk about very basic one in the beginning, just to understand how this algorithm works, uh, their logic behind these algorithms together with their pseudocode. Um, why actually you need to understand this is especially when you are applying the knowledge or the algorithms, you should understand what is behind it, right? So that we start with by looking at the basic machine learning algorithms, how what is the logic behind these algorithms. And then once you build the model, how do you evaluate? Because we build machine learning algorithms with existing data, but we need to predict new data or future data. So how can you generalize the input to the output? That is one of the interesting topics that we need to discuss. So evaluation and credibility are the two topics we are going to discuss, how you may use the data for model building as well as the prediction for the future. Then we are going to talk about the real machine learning algorithms, because we start with the basic algorithms, but the basic algorithms cannot handle the problems in the real world, and there are some issues, and how we may overcome these issues, we are going to focus in this topic. Then we will discuss the other topics. These topics we mainly talk about the supervised learning. Then we will also look at unsupervised learning ensembles and also the dimension reduction. Right. So those are the main topics that I have discussed. Right. Now, I told you like this is my plan, and since I didn't have, because when I talked to you, I realized some of you actually know in depth in applied ones, and some of you may have not learned during your bachelor's. So to get that understanding, I have a couple of questions and I want you to answer in the chat. The first question is, those who have already done machine learning, what are the topics that you would like me to talk during this module? So apart from this list of topics, because I know some of you are working in the industry, what are the topics that you are interested to see in this module? So that is my first question. Yes, can I have some answers? So I'm going to stop recording for some time. I'm going to pause. Okay. So before we start machine learning, let's briefly discuss what a data mining is. Data mining is actually a process you will see, which we can use to extract implicit, previously unknown, potentially useful information from data. So data as it is not useful. Always we use different techniques to convert data into information. So usually what we need is we need some algorithms, the programs to detect these patterns, right? And not only that, I mean, for example, if you look at where the machine learning area today, we have a large number of machine learning algorithms are there, but what we need is good prediction, isn't it? Because there you can find some pattern, you can create model easily. Nowadays we have infrastructure, cloud based infrastructure, for example. It's easier nowadays. The problem is all these patterns that we will actually get from all these algorithms are not very interesting. So the first problem is most of these patterns that you are going to get are not really interesting. And this patterns also may be inexact, which means there might be issues uh, in the models or the patterns that you will get. And the third one, remember, this area is totally depend on the data. If your data is not in good quality, then you are we are in a problem, because data may be garbed or missing, which we might not be able to get any useful information from that. Okay, so as I told you earlier, the area of data mining is actually a process. This is called CRISP 2.0 version, where they identify 6 different phases, which where we can talk about the data mining. So data mining in general, we can see it's a process of discovering patterns in data. So as I told you, it's an iterative process, and you will notice nowadays we talk about data science pipelines, where you can see that we will have to follow a iterative process. So usually we start with understanding the business, which means when you are given a problem, first we need to understand what the context is, the business we need to understand, right? Now, for example, if you want to identify patient information from electronic health records, okay, first you need to understand the health domain, isn't it? Then, once you understand the business, then the second one is you need to understand the data. Now, for example, if I take the health information, you might have, patient name, patient age, the weight and the height, and, other tests, the blood group, you need to understand what each of these data is. Now, for example, the age, we know there will be some range of values. The weight and the height also, you have a range of values. So you need to understand what each of these values mean, and the range, the domain of the values for these data. So then the third is you need to prepare the data. Now, for example, if the data coming from a database, where especially in relational database, data is scattered, which means you have to denormalize. You have to combine the data to get a flat file, and then we have to learn from those. So that means we have to prepare data so that you can actually use. And when you have large number of features, for example, you have to select what are the best features and so on. So that also comes under data preparation. Then we have the modeling, where we create some data models for a task at hand. For example, if it is a classification, let's say you want to separate out cats from the dogs. One example in vision domain, like you have a set of pictures of cats and the dogs, and we need to develop a program where when you present a new image, the program is going to decide whether the image is a dog or a cat. You know? So that part only will be modeling, and the model building you can see back and forth interaction with the data preparation. Then you have evaluation. Evaluation in simple terms, we are going to have a separate session for that. Evaluation in simple terms, what it means basically, we are trying to evaluate how good this particular data model that we have developed from the previous one is good for predicting future data, predicting unseen data. And once you are satisfied, then we go for deployment. Right. Next, the machine learning. Now, the machine learning, you will see, will be a part of this. So before we talk about the machine learning, let's talk about the learning. We all are learning from the day we came to this world, and then we get the knowledge and the skills in various ways. So you can study, you can experience, or you can be being taught by somebody else, or you can become aware of the information, or you can just observe, or you can commit to memory, you can to be informed of a certain to receive instruction. So that's the basically learning. So then what is basically machine learning, right? In simple terms, you might have seen people generally say it's a learning from examples. So when you want to learn something, when you want a computer to learn something, you present some example. In our cat and dog problem, so what you are going to put is you're presenting cats and the dogs, right? And then we made the computer learn to separate out the cats and the dogs, right? And particularly the machine learning area is focus is improving the performance. So always remember there are various overlapping areas in this particular area, but machine learning particularly focus on how we improve the performance of the algorithm, right? That is where we always focus on. Right. Now let me have some formal definition for machine learning. So Arthur Samuel is a person actually worked with the computers in 1959. He started talking about this. So machine learning, according to Arthur Samuel, is a field of study that gives computers the ability to learn without being explicitly programmed. Now, you guys know when you program, we can have some rules saying if and then kind of a rule set. If you are typing if and then by yourself, we call it you program explicitly because you are trying to implement the logic. Whereas what happens in the machine learning is you input some data and the program will output that logic, right? And the second one is actually from one of the earlier researcher, Tom Mitchell. He's the one who actually wrote a machine learning related book. I think it's the first book on machine learning. So he generalized this idea of learning from examples. He said, well-posed learning problem, a computer program is set to learn from experience with respect to some task and some performance measure. And if the performance as measured by P will improve the experience. So let me give an example. So if I take my cat and dog problem, a computer program is set to learn from experience. E means our data. So in our case, our toy problem, it should be some pictures of cat and dog. So that's the experience. What is the task? Okay, we want to separate cats and the dogs. That's a task. So if you already have known about this data, then we can say it's a supervised learning. So the performance measure could be something like accuracy, how accurate the predictions of our program, right? So performance measure P. And it says if the performance measure on T as measured by P improves with experience C. So that means, in other words, if you keep on increasing the data you have, then it will improve the accuracy as well. So make a note of this, is very, very important. So in simple terms, we can say the machine learning is investigates how computers can learn based on data. So it's always you have to learn with data. Right. So I hope now you get an idea, right? I'm going to give you some examples where you are trying to predict whether we can use machine learning for these tasks, right? So I will give you first example, right? Tell me whether we can create, right, program to automate email sorting based on different labels, like maybe work, personal, and maybe spam and so on. So is it possible with the machine learning? So let me list some topics, right? So here is the task. Task one, I want everybody to answer this. Task is, can you tell me whether this is suitable, right? I'm going to ask, right? I'm given the following topics. Tell me whether ML can be used for the tasks, right? So the first one is, my first example is automated email sorting. Yes. You can say yes or no. Can we use machine learning? What is the answer? Is it yes or is it no? Yeah. In the chat, I want you to think. Predicting a number in a sequence. Example, let me say something like 2, 4, 6, and 8. What is the next now? Can we use machine learning? Third one, customer service inquiry responses. Something like sometimes you can have a product and then you might have seen in the websites where customers can request some information And can we use machine learning to automate these responses? So that was the question. Can we use machine learning here? The fourth one is reading data from spreadsheet. You write a program and you can automatically read data and you can perform some calculations, right? Weather prediction nowadays, the raining. So what is the probability of, rain for today? Yes, I think this is enough. I want you to think about, can we use a machine learning? Remember, I told you machine learning means we use data, right? And then data we are going to convert into some useful information. And it should create the logic, right? So given these tasks, first one, when you answer, remember to type the number and whether it's yes or no. Let me start with the first one. So the automated email sorting means like we get email. Problem is normally we used to sort manually. Sometimes we receive email from our friends and family. They are personal emails. Sometimes we get emails for professional, meaning our work. Some could be some spam, right? Can we use machine learning? Yes or no? How many of you say yes? Those who say yes, can you raise your hands for the first one? Okay, we have only 7 out of 27. You are saying yes. Automated email sort, isn't it? What do you think? Can we use? I think the answer should be yes, isn't it? Because we can make labels from already existing data, and then we can build a model. And whenever you get a new email, we can decide whether it's personal or working or something else. Okay, so you can lower the hands now. Second one, predicting a number in a sequence. So we have a number pattern like 2, 4, 6, 8. We need to find the next number. Yes. Can we use, or is it suitable? Those who says yes, can you raise your hands? Yes, we can use. What do you think about the predicting a number in the sequence? Do you need machine learning for this? First place, the question is, why we are using machine learning? Usually, we will use machine learning for some complex tasks, isn't it? So is it a complex task predicting a number in a sequence? What do you think? Simple mathematical equation is enough, right? Don't you think so? Do you need a machine learning system for this? So I think the second one is a deterministic, which means you can use a very simple arithmetic algorithm, which you can use to determine the next number. Right? So that means I don't think machine learning is a choice for the second. Okay. Okay, you can lower the hands. Third one. What about the third one? Customer service inquiry response. You request something for a company. Usually we have chat systems and we want to automate it. The question is it possible? Yes, can we use machine learning to do that? What do you think? You can raise your hands. If you think it's yes, please raise your hand. Right? Customer service inquiry responses. Of course, you can use it. We can use the existing data and the responses to automatically generate for new ones. So basically what we do, the common ones, we can handle using machine learning, right? So the common ones we can put together, we can use machine learning algorithm to train the data set. The fourth one, reading data from a spreadsheet. What do you think? You can lower the hands. Data reading from a spreadsheet is a straightforward one, right? You don't need any fancy machine learning stuff here. So the fourth one, again, I'm thinking it should be no. Last one, weather prediction. How likely there be a rain tomorrow can be answered using weather predictions. Right. That also should be okay, right? Weather prediction means you can use historical data to make the prediction. Good. I think now I hope you have no issue of understanding a problem, whether it's can be solved using machine learning or not. Right. Now, let me briefly talk about machine learning techniques. That is what you will see. So basically, these algorithms we use to identify the patterns we call sometimes as structural descriptions. And these descriptions we can use to identify the outcome, or you can use it to understand what is happening, right? And then these algorithms can come from different domains. Now, for example, when you use machine learning algorithms, originally they actually come from artificial intelligence, or it could be even statistics, or it could be even a research on databases. Right. Now, let me show you some examples first. Right. Throughout my theoretical explanation, I'll be using this, the data set. This is actually developed by an Australian researcher called Ross Quinlan. And what he has developed is basically he developed this data set called weather data. And we are going to predict whether we can play or not based on these different weather conditions like output, temperature, humidity, and windy. So basically, we have different weather conditions, and based on these weather conditions, we are going to make a decision whether are we going to play or not. right? And this is the typically the data set look like. You have a set of features, in this particular case, outlook, temperature, humidity, and windy. And there's be a feature which predicts what we need. In this particular case, it's yes, right? So by the way, you will notice that there will be about like 14 instances, right? Okay, so now let me present you some outcomes or the data model. Now, if you use the data set and if you use a decision tool rule learning algorithm like Prism, that means you give or provide the data set as the input, the output will be some decision rules. So for example, when we program, we can write this kind of a structure, but remember the structure we have automatically, extracted from the previous data set. Right. Next, this is another representation. Again, the same data set we use to build another model, which is visual, is called decision tree. We will have a separate session on decision tree. For the time being, I can say in our original data set, we had 4 features. And here, how many features we see? Yes, originally we had 4 features. How many features you see here? And can you tell me why? In the chat. In original data set, how many features we had? We had 4 features, right? And how many features do you see here? Yes. Yes, we have 4. Originally, we have 4 features. But in the model, we see only 3 features. Can you tell me why? And any one of you? Originally, we had 4, but now we see 3. It means what? it means not all the features are equally contribute towards a model, right? So we had 4 features, but you will see only 3 features here. How this is possible, we are going to discuss, but remember, in this particular case, for the time being, you will see in decision trees, it will use only the features they need. So originally we had 4, but it uses 3. Okay, so this is another data model. So some algorithms will generate a set of decision rules like this. Some generates a decision tree like this. Both are you can see them as a white box model, which means you know how the decision has been made, right? Then the next one is comparison of association rules with the classification. Now in classification, in our example, we have a couple of different weather features, and based on that, we are going to decide whether to play or not. So our class attribute, or the attribute that we are going to predict, is play. Association means any association. For example, this is actually quite useful in what we call market basket analysis. Market basket analysis means when you go shopping, right? What items you buy together could be, extractors using association rules, which I will discuss, right? Why this is helpful? Now, for example, in a shopping mall, they can identify what people purchase together, and you can keep them together. For example, one of the foreign studies they used to say, when people purchase diapers for kids, for example, they purchase beer as well, goes together, right? So similarly, because sometimes you don't see any relation, obvious relation, but when you analyze the data, you will notice that they are related to each other, right? So usually you can see classification rules are very small, the number, but there could be many association rules can be used, right? Then another type of problem that we are going to handle in machine learning is finding numerical value. Now, for example, let me go back to the same problem. Now, in this one, this data set, we are going to predict whether we are going to play or not. At the same time, if you want to have a numerical quantity, you can change the data and you can have a number which says how many minutes you could play. So instead of saying yes and no, you can say that, okay, we can play 5 minutes, we can play 10 minutes, we can play the whole day, So likewise, you can actually change the values, right? If the value is a numerical quantity, then we are supposed to find the numerical quantity. So the simplest method that we can think of, which is called linear regression function, which is a simple linearly weighted algorithm. So you can see each and every attribute, you have some weight. Actually, your weight could be 0 as well. In that case, we can see that even here, you don't need on all the algorithms, sorry, all the features. Okay, I think we have seen some basic examples of machine learning, how the machine learning algorithm, the output, right? Now, let me talk about some application areas, right? So the first one, if you look at the application nowadays, machine learning is everywhere. So in here, I have listed some of the examples from the book. In science and astronomy, bioinformatics, drug discovery, machine learning is heavily used. In business, we can use machine learning for advertising, customer modeling, e-commerce, fraud detection. These are some of examples. In web, we can use it for search engine and bots. Right? So there are a lot of applications you can think of uh, looking at what is happening today in machine learning. Some examples, again, those are from the book. So the first example is on loan application. Now, as we work in some place, we used to apply for a loan, right? So we can go for a loan. Let's say I want to buy a car, then I can apply for a car loan or a personal loan. Right? So then that usually gives you a form where you are supposed to fill your demographic information, your name, where you are, your address, all this information, plus your financial information. So what are the accounts you have, whether they are saving and all, and then whether you have properties. So everything they will collect, right? Now, once they collect everything, the question is, should the bank give you the loan you have requested, right? And usually, uh, most of the time, you can use simple statistics to solve this problem. No issue. But there are some margin issues where we have 50-50, right? That means sometimes the human cannot decide whether to provide or not to provide, right? And remember, those are the profitable cases. Why? When you are merging, right? When you have borderline, so you have both ways, right? So when you have like 50-50, you can make a decision, then it will be difficult you to understand on this side. So you can use machine learning. So in this particular example, they talk about 100 training points, right? They are all border collection, which means the human cannot decide whether to provide or not. And they have collected attributes like age, youth, years, and years with the bank, other credit card processor, and so on. So if you use machine learning approach and when you learn the rules, they say it's about 70% correct, where a human expert can only barely manage C. Right. So once you use the decision rules, the beauty comes in. So you can always reject, but you can explain the customer that why you have rejected if you use command line interface. Right. Any questions from this part? Yes. Any ideas? Okay, let's move to the next one. So as you can see, when you have borderline cases as in previous one, so there the customers are more profitable for the banks. And remember, you should make good guess for those customers. And usually what will happen is these borderline cases, if you have provided it to human, it will be 50% because you cannot make that decision. Some may say yes, some may say no, and then it's 50%, but they have showed in the example that the accuracy is about 70%. Right. Next, actually from computer vision problem. Now, these are some of the aerial images taken on the sea, and you see some patches. So these are called oil sills. That means sometimes the boats, due to leakage of fuels, then these forms oil sills like this, which harm the animals. So what we need to do is you need to identify the locations and then you have to remove them. Otherwise, it damages the environment. So that was the problem. So they were collecting aerial images of the sea and they were just trying to understand whether this is oil silk or not. The problem is visually it's very difficult to understand. Right. So radar satellite images of coastal waters, the problem is you have to detect oil cells in those images. So they appear as dark regions. You have a change of size and the shape. And basically it's not easy because this can be caused by weather conditions such as high wind. And the problem is if you use humans, it will be a very expensive process. So what they did, they have used machine learning approach. So what they have did is they taken dark regions of the normalized image, and which we will do in our vision problem as well. So maybe we have to decide on predefined size of the image, and then we have to, identify area of interest. Right. So you extract the dark region from the normalized image, and these are the attributes they have created. So you can see size of the region, the shape, the area, the intensities, the sharpness, jaggedness of boundaries, proximity to other regions, info about background, and so on. Right? So these are the algorithms they have generated. On the other hand, there are a couple of constraints as well. First, and the major problem is you will get only very few examples because oil seals are very rare. Second, you have unbalanced data. For example, if in this particular example, you might get about like 5% and 95%, very unbalanced data. And not only that, sometimes the single place or single oil slick may comes as multiple images. So we need to reduce the total error of this. So they have actually used machine learning to do that. The next one is called load forecasting. So in this particular case, for example, in our case also, we heavily depend on water. And then some time you can generate the electricity you need, sometimes not, right? For example, due to weather. So if you can properly set this up, you can save a lot in this. So in the problem, what you get is manually constructed load model that assume normal climatic conditions. And the problem is just for weather condition. And then that model, you can see the following. So in machine learning approach, you can use the prediction and you can also correlate the most similar days. Then you can create attributes such as temperature, humidity, wind, speed, or cloud count readings, the plus difference between the actual load and the predicted load. So you can see average difference must 3 most similar days added to the static model. And then the linear regression coefficient from attribute weights in similar fashion. Right. Now that we have looked about uh, the data mining and machine learning stuff, there could be ethics involved. Now, ethical considerations are very serious nowadays, especially in AI domain, because it's very difficult to anonymize data. So sometimes people, when they want to develop the systems, they ask you to anonymize. That means if you have personal information, they remove, they change, they do something so that nobody can identify. But the problem is you can easily identify any of the person using the postcode, the date of birth, and the gender. So it's possible. So data mining, we can always see it's used to discriminate. So for example, loan applications, if you use things like the gender, religion, and race, it's unethical. And then we have ethical situation depending on the application. Some information okay in medical domain. So these software is okay for a medical problem. And then there are some other problems as well. For example, area code may be correlate with the race. Right. So that is the introduction that I actually prepared for you. The next one, we are going to try to understand what are the types of learning available in IT. So we have basic types of learning, and then we are going to talk about the types of inputs, the idea of concept, example, and attribute. And we can also discuss preparation of input to a Weka, the Java-based problem. Right. Now, 4 things. So any learning, we talk about a lot different types of learning. So here you can see classification, we sometimes call voice learning. And then we have association learning, clustering, and then numeric prediction. So the classification means we are going to predict a particular class. In our play attribute, the play is the class. And all the others are right, the other features. Then the second one is association learning, detecting associations between frames. And then we have clustering, we can identify similar groupings. And then we have numerical prediction, that means you predict a numerical quantity. Right. So let me give another small exercise. Right. I will give you some examples. Tell me what is the type of this, right? So for example, I'm going to take the same problem. So I want you to identify the type of problem, right? Identify the type of the problem. So we have to identify as classification, clustering, association, and numeric prediction. Right? So here are the examples. I will give you about 8. So the first one is predict whether a patient has a particular disease. We have social media grouping. Right. Can you identify the 4? Right. What are these 4? Are they classification problem? Are they clustering problem? Are they association problem? Are they numeric prediction problems? I want you to type the answer in the chat. Let's start. So the first one is predicting whether the patient has a particular disease. You know, it comes under classification of the supervised learning. So depend on, let's say, cancer or non-cancer, we can collect data and then we can build a model, we can predict. And then the second one, identify products that frequently co-occur together, right? Meaning that I told you, like in market basket analysis, basically what they do, they get the data, they look at what items they frequently co-occur, right? So which means it's association learning. The second one should be, right, association learning. It's not a number, right? Products. So for example, we can say milk and cereal can go together, right? But that you have to identify using the data. Third one, social media grouping. So you can, for example, you can have different types of, social media groups, different communities, different interest, That's basically clustering, right? This is called clustering, where you can actually group the similar, based on similarities, you can decide how to group them. Fourth one is a numerical prediction, real estate evaluation. You know that there are evaluators who decide on the pricing, but based on what is existing, we can build a model to automatically estimate the valuation. Very interesting problem, right? So for example, let's say there are rented houses. Depend on rented houses, we can depend on the number of rooms and the facilities, we can make some estimation, right? So this is useful sometimes even in things like purchasing cars, other equipments, mobile phones. For example, you can compare whether this is very useful. So numerical prediction can be used because, for example, in this particular case, it could be something like a house price, which you can estimate. Right, good. The last part of today's session, I want to check your knowledge on Python. But before that, can you raise your hands, those who have already learned Python at some point, somewhere? So we have about 15 minutes or 10 minutes. So we can have a very small session. Okay. So you had a course unit. Okay. Thanks, Chintak, for sharing that information. So that means everybody knows this. How deep you know? Have you done things like NumPy, Pandas, Matplotlib? Have you familiar with those libraries as well? Okay, so that's great. So which means I don't have to teach them, right? Okay, let me have a quick game then, small quiz. So please go to www.kahoot.com. Please log into kahoot.it. We are going to have a quick quiz on Python just to see how comfortable as a class, as a group, how comfortable you are with Python. So type your first name as your nickname and then use the game pin 3029616. So let me type the website. And the PIN number is okay. Let's have like about like 10 questions and just to evaluate. So let me start. Okay, I hope you are familiar with the system, that those who are not familiar, is just for your information. Now, in this platform, to get marks, you have to select the correct answer given in 4 different colors. And the next is, if you answer quickly, you get more marks. And if you answer consecutively correct, then you get more marks. So let me start. Yes, the NumPy is one of the libraries we use, and it's known as numerical Python. Yeah, in this one, actually, the question is on creating NumPy array. And what you see here is it's a column array. If you don't understand, I will have a small session on that. And when you say age, dot shape, it will give you the dimensions, the number of rows and the columns. So in this one, since it's the column vector, we have 3 by 1. 3 comma 1 is the correct answer. Three more questions to go. So Python is a high-level programming language. The type will tell you what a data type is. Last two questions. Last one. We'll stop at this point. Right, let's finish for today then. Okay, we can see the results. The third place goes to Image. Second place goes to Dushan. And the first place goes to Chintaka. Congratulations. We have fourth and fifth places, Akila and Kanchan. Okay, nice to meet you guys. We'll meet on next week and I'll have an update content I will have. And I will also upload some information on the LMS so that you can refer the material we covered today. Thank you very much and we'll meet next week.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.